Hello, everyone who is logging in this evening. Just wait a couple of seconds more while everyone starts logging in. So thank you very much for being here today. This is the University of Sydney, and we'll try to have a nice evening for you, so you can learn some of the things we want to teach you. So we're the Faculty of Engineering, and we're very lucky today to have our three areas being exposed today, and we're going to be talking about those. So we have first Mr. Anthony Cady from the School of Engineering. Anthony.
Hey.
That's Anthony. Then we will have, after Anthony, we'll have Dr. Karen Han from the School of Computer Science.
Hello, everyone.
Thank you, Karen. And after that, we'll have Dr. Ken Chang from the School of Project Management.
Hello, everyone. I'm Ken.
Thank you, Ken. Thank you, Karen. And Anthony, off to you.
Thanks, Carlos. Well, welcome to the University of Sydney. My name's Anthony Cady. I'm the Director of Professional Practice in the Faculty of Engineering. So I want to start out this brief presentation by just asking you a simple question, which is, why are you planning to study? And maybe you're planning to study just for fun, or maybe you've got super rich parents and you don't need to get a job once you graduate. Your parents will support you forever. Maybe there's not too many of you in those categories. Most people, when you ask them why they want to study a degree, it's because they want to get a job at the end of it. So if you're in one of the former two categories, you probably don't need to listen to what I'm going to say. But if you're in that last category, you want to get a job when you graduate, and preferably one that pays really well, then everything I'm going to say is really important for you. So the first thing is just a little bit about statistics, which is, do graduate engineers get engineering jobs? And the answer is absolutely they do, but not always as engineers. You can see these bars here in the darker blue. They're the percentage of engineering graduates in different age groups that go on to actually work in engineering roles. And the light blue are the ones that go on and work in other roles. And you can see that the ones that actually go on and work as engineers are less than 40%. So what that actually means is that engineering is an incredibly powerful degree that can open up a lot of different doors for you. Now, this is data from the US, from the Australian census. And you might say, well, that looks like rubbish. That can't be right. 40% of people doing engineering end up as engineers. That can't be right. Well, here's the same data from the US census, and it basically says the same thing. And you can see the block in yellow at the top here. These are the people who've studied engineering at college or university, and you can see less than 50% of them actually go on and work in engineering. This one actually shows all the other areas that engineers end up working in. So again, you can see engineering is a very powerful degree that will open up a lot of different doors. Basically, engineers are in high demand because they're very good at solving complex problems. So what is it that's actually going to lead you to getting a job once you graduate? It's actually getting harder and harder. Well, what you actually need to do to present to a prospective employer is what we call a strong value proposition. And what you'll have with a strong value proposition is when your skill set matches the specific requirements of a job that you're applying for. But that's not all. You also need to know about your own personal attributes and match that with the company culture that you're applying to. So it's no good just having the technical skills and the transferable skills. You actually need to be able to fit in to the company as well. Makes sense, right? So when you're going through your degree, it's really important to be aware of what your strengths are and your technical skills and your transferable skills, and do lots of extracurricular activities that will bring up your evidence in those areas, and also learn a bit about yourself and your personal attributes. I'll be talking a bit more about this as we go. Now, in terms of how companies hire people, they actually mainly fill from within their own organisation. But if that doesn't work, they ask their current employees, do they know anyone that they could recommend for that job? Okay, and then they'll accept targeted direct approaches by job seekers, people who write to the company and say, I really want to come and work for you and this is why. And then if they get desperate and they still haven't found someone to fill a role, they might go and pay an agency. And then if they're really desperate, they'll put a job ad out on Seek or one of those other job boards. So most people actually spend most of their time looking at job boards and saying, that's how I'm going to get a job. But in fact, that's not how organisations hire people, right? So you've got to match your job search skills to the way companies hire people. So networking, getting referred by trusted contacts is by far much more effective than looking at job boards. So really important that during your time at university, you network and actually build up those contacts. And, you know, getting resumes sent by email is probably the last approach. So there's lots of different ways you can build up those networking skills and learn those extracurricular activities that we talked about. The clubs and societies on campus are fantastic. You've got, you know, Engineers Without Borders, and you've got the UCID Rocketry Club, who went to the USA a couple of years ago and won first place in the world rocket competition. In engineering, we've got the Professional Engagement Program, which I'll talk to you about shortly. We've got a range of other programs, ESIPs and MIPS, Industry and Community Projects, Jacaranda Flame Consulting, the Sydney Leadership Academy, mentoring programs, and of course, the faculty runs lots of events where people from industry come and talk on campus and recruit people and things like that. So all of these things, apart from the professional engagement program, all of these things are optional, and they're opportunities for you to take up if you want to. No one's going to force you to do it, but it's really important that you actually do take up some of those opportunities. Not necessarily all of them, but some of them. Just very quickly, if you are coming to study engineering at Sydney Uni, you'll need to complete this professional engagement program. And what that does is it requires you to do 600 hours of professional practice spread throughout the 4 years of your undergraduate degree. And you can see that there's 3 different categories of hours: engineering focused, non-engineering focused, and engineering work experience. And so we will help you in this program to get that experience, those experiences, and track your competency development over the 4 years and give you the right language to be able to talk to employers about what it is you've been learning and why you're a good match for roles within their organisations. What professional engagement is really there for you is moving you away from this mentality, which is how can I pass the exam, to how can I apply this knowledge. Okay, employers want you to be able to take the knowledge that you're learning at university and actually apply it to solving real problems. So you're not going to do that just by memorizing stuff and passing exams. You've actually got to understand what you're learning and be able to apply that knowledge. So that's really important. That's why you have to understand what it is industry is looking for and the sorts of things that you'll be doing in industry right from first year. No good to be understanding it in 4th year. You've got to learn it right from first year. That's what the professional engagement program is going to help you do. I also mentioned Jacaranda Flame Consulting. Just very quickly, this is a mock consulting company that we run in the faculty. At the moment, we've got 75 students, mainly in 3rd year, who are third and fourth year who are working on 13 real industry projects. They work full-time, 5 days a week, and we have an office off campus. We have industry supervisors and mentors. We've been running this for about 5 years, and that provides very authentic consulting engineering experience for students. Again, it's an optional program. It's up to you if you want to do it. These are some of the clients that we've had. So one of the projects that we had a couple of semesters ago was designing a new vertical transport system for the Badgerys Creek Airport. So not lifts, not escalators. In a couple of years' time, you'll be able to see what the students from Sydney University designed for a new vertical transport system at the Nancy Bird Walton Airport. Dolby, various other companies and community groups. So this is just a sample of the clients that we've had. We've had many more. Another option for you to take up is actually a unit of study that's run by the university called Industry and Community Projects. It's a bit like JFC, but where in this case you'll be working with students from all other faculties. So you might be working with students from music degrees, or arts degrees, or business degrees, or health degrees, and you'll be working on all sorts of amazing projects with industry partners. So they're another opportunity for you. So just coming back to this diagram, I've talked about some of these. You'll learn more about these as you come to the university and engage in the programs. We have a really fantastic mentoring program. So first year students who are starting out in their first semester, everybody gets allocated to a mentor who is a more senior student, and you'll meet with that mentor a couple of times during the semester, and they'll help you through getting settled into your classes and navigating your way around campus and understanding the academic requirements of what's expected of you in your various units of study as well. So I hope I've given you a bit of a flavour as to the engineering practice components of your engineering degree at Sydney Uni. And that's all I've got to say. So I'm going to hand you over to, I think I've got one more slide, which is just a summary. These are just the main points I'd like you to take away from my brief presentation. And I'll be happy to answer any questions at the end. And I believe I'm handing you over to Karen now.
Yep. Okay, hello everyone. I'll just try to share my screen. Can you see my screen? Okay.
Yep, it's all good.
Thank you, Anthony. Yeah. Okay, so my name is Karen. Hello, everybody. So I want to introduce myself first. I'm a lecturer and currently working as a director of outreach education and School of Computer Science. And I did my Bachelor of Computer Science in first class honors and the PhD in Computer Science AI, and received that Australian Young Achiever Award in Teaching Excellence and Teacher of the Year 2020. And been actually working in AI and NLP area, natural language processing, and worked with US Air Force, US Navy, or Australian Defense Department. And then Microsoft and Google, been actually working these days, and currently have 9 PhD students. I actually saw like several questions about the PhD or exchange or something. I think I can answer most of it in this slides. So firstly, I want to, Anthony been explaining about this engineering overall, but I want to talk about a little bit detail for the computer science. So starting at the University of Sydney in the School of Computer Science, we're majorly actually working with like different types of sectors, as you can see, artificial intelligence, machine learning, or computer network and security, which is including the cybersecurity as well, and human-centered technology. It is more like using this health informatics as well, and then information and system and service computing like web or any kinds of interface related. So using this one, we have this Bachelor of Advanced Computing. If you enter this university with the School of Computer Science, you will start with this degree, Advanced Computing. So it's going to be 4 years full time. And of course, you can early exit after 3 years, but that's your choice. But the 4th year actually going to be really helpful to achieve better try with more industry project, and also you may just try with some more research that you can actually choose any of 2 of them. So and then we try to have these major with computer science and information system, and then software development and computational data science. So that's what we actually have major now. So as you can see that with that 4 majors, you may just try to select another majors as well, as you can see, like music major, marketing, any kinds of thing from this shared pool. So this is the shared pool. Like from here, you can actually combine this, our advanced computing majored with different majors here, which is related to the computer science, but you can actually choose any of these shared pool and try to do something new thing. So one of my students actually has been working with computer science major and linguistic, and they just trying to make this focusing on more deeply inside this natural language processing, and also understanding this mathematical and also computer science, trying to see how we can actually program that in order to make software. And for the software development plus music, or some of the students actually found out design, computing design, or design computing, and the software development major, and she got a job in Japan, the game company. So there are really different students actually have different idea in terms of having that. So that is after we got this all these shared pool, then you can just choose and make it up this advanced computing. And there might be some students, oh, I don't want to choose from this shared pool. In that case, that's totally fine. You can just try to just focus on one major, computer science major, and then you can choose one minor as well. Or you can just choose like 2 different computer science related, like computer science major plus software development major, like that. So it depends on you. But we can actually find out this how you can get the skills in order to do something that is you're interested in. That's the point that we're working on this degree. Okay, so based on that, also, in addition to what Anthony actually mentioned, we have a DL Scholar program, and so students actually got really high ATAR, like 98 ATAR, then obviously they will just automatically join as a DL Scholar. And DL Scholar students normally have this Global Mobility Scholarship. The reason why I mentioned this one, I want to say that University of Sydney actually got really great opportunity in terms of this exchange. Maybe there might be some students actually thought, now it's COVID-19, we cannot really go anywhere. Then, yeah, except that happened. Normally, our students actually go to UCLA or Harvard or Stanford even. One of my students who is doing the PhD now, he actually went to Stanford for the exchange, and he did that machine learning there, and then just trying to go back. And there are some questions asking about like a year or the semester, which one is possible. It actually depends on your application. So you can actually apply for the year-long exchange or a semester-long exchange. You can choose it. So there are really different types of international opportunity, exchange opportunity that you can actually try. So the undergraduate scholarship, we normally have this international scholarship, but we also have first year domestic scholarship as well. If you have any interest in this domestic scholarship, yeah, you need to double check the domestic scholarship website. In the university website, you can just see that there's a computer science sector, and then find out this domestic scholarship. But if you have any more question, you can just put it in the Q&A. I can just answer it for you. Okay, so how we develop and shape the skills with the industry. I want to introduce several cases because there are many students actually ask about these industry. I want to say that our graduate in the computer science normally actually go to the IT companies, but not only these days. A lot of students actually trying to make this combined degree, as you can see that with the shared pool. And with that shared pool, they can just try to do like medical science or the finance together, so they can get a job in the Commonwealth Bank or different types of finance area, also hospital or medical department. The reason why we got like our graduate got a lot of job from there is these days, most of the industry, medical or finance or other area, all of them, they actually need the data scientists and who actually understand about this cybersecurity or the machine learning, any kinds of people who can actually deal with these data. And then currently it's all actually making this electronic data now. So using this electronic data, they want to do something with this data, full of the data now. So they need to know who actually understand about their expertise, like medical or finance or business, and then also understanding about how they actually handle this with computer science techniques. So that's how we are actually working. So, and I want to introduce several industry projects that we can actually do during computer science degree. In the third year, we have the undergraduate capstone project with industry for 1 semester. So in 1 semester, you have a group, and the group of the students will actually join with different types of industry. So for example, if you're interested in, after I finish all 3 years degree, I like programming and more like a software development part, then you can just really work with the Atlassian or freelancers, this kind of really software development type of industry. They actually share some projects in our undergraduate capstone. And if you like, after you finish it, you feel like, I want to try with like AI and machine learning, because in your third year, you're going to learn AI there. So you may just get a project with Amazon or Google, or if you like medical or specifically like business field, then also the finance department, or also like Commonwealth Bank, like different types of industry, or even the hospital actually have this project. So you can choose the project and then making a group with the students and then trying to finish a project in 1 semester. Is there actually a good chance to have a connection with the industry people? And one of the good case I want to introduce is the summer winter project. So undergraduate students actually have the summer or winter break. We have this industry opportunity. And one of the successful case I want to introduce is this student actually, after he finished the third year, he got the software development and AI and the data science skill. And he chose that project, which is introduced from this Department of Defense. And based on that, using during the 3 months, he's been actually working with making up this dashboard and then finding out this the person, when the person actually are wearing the device, and he's just trying to detecting and finding out who is the person who actually wearing this device now. So based on the human behavior, he tried to use this AI technique and data science technique in order to find out whether this is the person who can get the access or not. So like that kind of, this is the successful case. And this was decided and selected as a NSW government successful case. And then also, this is I actually made it with this Google together this year. So final undergraduate student actually have the Google and university during the semester 1, and we actually let student experience the industrial and then academic researchers' life. So we invite this all these professors and also the Google developers and researchers, and try to talk with them and understand how they actually like. So what sort of skills that you can actually learn. So this is how we actually have the Google and university together. Okay, so yeah, this is the end of the lecture, end of the seminar for this computer science. Yeah, thank you. So I'll just leave it to Ken. Thank you.
Thanks very much, Karen. I'm going to just try and share my screen, so please bear with me for a second. Here we go. Just adjust that slightly and should be ready to go. All right, well, good evening, everyone, and thanks very much for attending tonight's session. Hopefully it's been very informative. I'm sure it has, and I'm hoping to add more value to it, but more from a project management perspective. So my name is Ken, and I'm the director for the undergraduate program at the School of Project Management, Faculty of Engineering. So I'd like to share with you a bit about the role of project management in society, and also along the same lines like Anthony and also Karen, talk a bit about the kind of skills that you need for a project management career and what we're doing at Sydney Uni. So most of you will know, for example, at Sydney CBD, right? Most of us, we know that the light rail has actually has been launched as of, I think it was last year or a year before. And while it looks glamorous and it's sort of revitalized George Street, for example, it did come at a cost. And the RBA governor, for example, there was this article 3 years ago talking about how there was just poor governance, and the whole budget for the entire light rail was over expended by about $1.3 billion. And so there was evidence of poor governance. I mean, if you look around the world, looking at infrastructure projects, for example, looking for project failures, you'll find plenty. And in fact, so much to the extent that John Grill, who's one of the benefactors of the university, he's been questioning why is it that here in Australia, we still have to outsource our top project managers from other countries, and why don't we have that capability? And so when we wanted to plan for the degree of Bachelor of Project Management, we had a chat with a number of industry leaders, and these are just an example of a few. And most of these leaders and those who are actually professionally practicing project management at the moment, they always tell us that they never ventured out to be a project manager, and that they are accidental project managers. And most of them started, for example, as engineers or computer programmers, and they grew in their line of work to lead people, to lead small teams, for example. Suddenly they were reading contracts. They had to pick up the phone and negotiate with suppliers on delivery times and so on. And so because of that, they had to upskill themselves. And so they recognized that, the training that they received wherever they did wasn't sufficient. And so they really wanted to acquire those sorts of project management skills. The skills to not just control and steer the project in terms of making sure it's under cost and making sure that you're delivering on time as promised and keeping the different stakeholders satisfied, but it's also about negotiating with different stakeholders and the politics, and making sure that you understand how to navigate the tension. So there's aspects of psychology in there, there's aspects of emotional intelligence in there. There's also technical aspects which deals with scheduling and risk analysis and so on and so forth. And so when we design the undergraduate degree in project management, we simply had one statement that defined it for us: the need to develop these critical systems thinkers who get stuff done. And if you look around the demand for project managers, if you just do a Google search for project management jobs, for example, at seek.com.au, you'll find that there are at least, for example, 40,000 plus jobs across the Sydney region or New South Wales. And one of the key things about project management is that it's not one of those jobs where you can automate easily, right? So for example, in an article published in ABC News, this was in 2017, they referred to one study which looked at the kind of jobs that could be automated. And so one of the jobs that would be automated, they predict in the future, are things like taxi drivers, because there's going to be, driverless vehicles, and we're already seeing that sorts of things. Tilers are people who do jobs that are very repetitive. They can be automated by machines. But, contract program and project administrators, the likelihood of automating that is fairly, the probability is fairly low there. And so that's exciting. We've got engineering professionals as well at 10%, and ICT managers. So it's really us, right? Anthony, Karen, and me here, which is really great. And so at the University of Sydney, especially where project management is concerned, in fact, we are actually ranked as #1, right, in Australia. And I'd like to highlight this. This is in the Financial Review, talking about how at the University of Sydney, project management in Australia, we're leading it. In the world rank, we're #12. And according to Associate Professor Pollack, who's my colleague and friend, now he says that because we're doing sort of cutting edge research in project management, we can bring those findings into our classrooms before even the next set of textbooks are actually published. And so that's our advantage. And here's a quick table just to show you, and this is all available on the internet, so you can Google it and find it. Australia is #1, University of Sydney, project management there, and globally we're ranked #12. And so what are we actually offering? So we're offering different pathways for you to get into project management. There are basically 4 pathways that you can do project management. #1, you can study the degree, which is a 3-year degree, a guaranteed ATAR of 86. And then you can also basically have a major and a minor. So you can just choose a major, or you can do a major plus a minor, or you can combine it with like an engineering degree, for example. And that's a 5-year degree with a guaranteed ATAR of 92. Now, those of you who might be saying, well, I'm more interested in science. I want to be a biologist. I want to be a physicist, but I'd like to upskill myself and I'd like to do a bit of project management just to know what it is. Well, that's fine. If you're doing that kind of degree, you can still choose to major or minor in project management through the shared pool that Karen was just talking about. So very quickly, just let me show you a structure of the 3-year Bachelor Project Management degree. And that's sort of spelled out over there. So you can see the list of subjects that we're offering, from introduction to project management to facilitation and stakeholder management, right? Now, stakeholder engagement is really huge. Councils and government leaders, they all talk about stakeholder engagement with communities and whatnot, and they want to co-partner and co-create value. We also teach not just facilitation, but effective project communication as well, systems thinking, critical thinking, and then you can see that we also teach you the more hard skills, the technical aspects of project management when it comes to time, cost, resourcing, and so on. There's conflict management, there's the legal aspects as well. And in your final year, you'll be doing a capstone project where we put you with industry partners. And so for 2 semesters long, you work on that project with that industry partner. Now, in terms of majors, what could you be studying, right? I'll show you in a second, but I'll just like to say that in your 3rd year, you can choose 2 electives that you wish to study. So we have a pool of subjects within project management. So if you're interested in, say, international project management, or if you're interested in something like scheduling or project cost and finance, you can choose that in the elective spots. But let's talk about the majors. Now, in terms of majors, just like what Karen mentioned before, you can choose from a shared pool, but most students who come into doing project management, a number of them choose construction or the built environment, which is fairly popular. But then we have students who are interested in, let's say, film studies, or they're interested in finance and accounting, or they're interested in design and architecture. And this is the same slide that Karen has showed before. We've got actually more than 100+ majors, more than I can actually remember. And so this degree is fairly flexible in that sense. If you're doing a standalone degree, you can choose to major and apply project management in any of these areas, which I think is really fantastic. Now, I'll show you a bit about the salary, so this is a Project Management Institute salary survey. It's a public document that you can download from the internet, and it's very detailed, going through nation by nation, industry by industry, showing you what sort of earnings are available. This is the latest edition by the Project Management Institute. And in Australia, you can see that the mean salary, for example, sits at about nearly 150K, right? Now, with bonus and all sorts of other incentives, the total compensation ramps up to about 157K. And that's quite impressive, right? If you break it down by different industry, you'll see that in engineering, for example, you're earning around 160K. If you're doing IT, for example, in information technology, and you're doing project manager work in that industry, it's about 141K. And if you're in construction, for example, it's about 137K. So quite interesting. Another thing I'd allude you to is to go and check out what actual, our tax payers, what do they actually report? If you want to know how much a job pays for Australian occupations, just do a Google search for, the highest job salaries, and there's this article in the ABC News. You can actually type in a search field, and it draws out the database from the ATO. It shows you the average and median taxable reported incomes for the year 2018 to the financial year in 2019. So in this case, for example, a project manager working in the construction space, that's an average of about 115,000. That's what's reported. There were 59,000 in total. And with computing professional who works in project management, they earn around 126 as an average. There's the clear gender difference there, where you've got males earning more than females. So that's interesting as well. Now, a way to connect with us is sometime around the school break in October. We'll be hosting a project management camp, so please keep a lookout for this. It's an occasion where we immerse you into, generally, if it was face-to-face, 2 whole days of project management activities. We give you a sense of what it's like to be in University of Sydney, and also we'll take you for a site tour. In the past, we've taken students to Google. Recently, we've been taking them to Atlassian. And these are meant for students in years 10 to 12. So keep an eye out for this. There'll be a call for people who want to participate. Because of COVID, we're going to take this online as we did last year. But the face-to-face one is obviously a lot more fun because of the site visits and things like that. I'll leave you with the last slide, which is about scholarships. I know Karen's kind of touched on this as well, and Anthony as well. But just do a Google scholarship engineering, Google scholarships engineering at Sydney University. You'll see there is a number of scholarships that pertains to project management as well. And of course, further information, my details are here. And I think with that, I will just close my talk and stop sharing the slides. And I wish you guys all the best. Thank you very much.
Well, thank you very much for that, Ken. That was very informative, and as well to Anthony and Karen. So now we're going to get to the next part of this session, which we will start answering all your questions live. So for those who have been putting the questions on the Q&A, there's a thumbs up. If you see a question that you wanted to go up and we answer, or you want us to answer it quicker, we'll try to do as many as we can. So here we go. So one of the first questions, and they've been asking multiple questions regards to double degrees. Double degrees, combined degrees. That's when you do 2 together. In the case of engineering, for example, you can combine with project management, and you can combine it with science, you can combine it with business, you can combine it with other areas. No? In the case of advanced computing, as Karen informed, and she showed on the slides, you can also do multiple combinations. Therefore, first question, do I need to do a single degree or to do a space engineering degree? So for those students who think, do I need to finish one degree and then I do another one? No, you can enroll in what is called a combined degree. So you could do, for example, civil engineering and project management. And you enroll in one degree that is combined degree, civil engineering and project management together. You don't have to finish one and then apply for another one. You apply for one all at once. To my panel, is there anything you would like to add to that area? Because many questions asking about double degrees and combined.
Look, I'd just say not every combination is possible, but a very large number of combinations are possible. So I think, you know, check on the website or send an email inquiry through if you're not sure about your particular combination. I've certainly been answering quite a few questions on the chat there while Ken and Karen were talking. And, you know, someone was asking about, can they do biomedical and electrical engineering at the same time? No, not really. You can do one as a major and then you can choose electives from the other. So you can kind of, you know, major in one area and pick up a few bits and pieces from other areas. But unless you do a double degree and that you do the second degree in that particular area. But if you're two in engineering, it's not really possible.
Thank you, Anthony. So next question. I'm actually interested in AI and was thinking about software engineering. So what is the difference between computer science and software engineering? I suppose it's for you, Karen.
Yeah, I saw another questions down there as well, the same question, I think. So the computer science is more like a study how the computer works, mostly like theoretical and mathematical perspective. So you should choose the computer science if you like logic and also specialized field like artificial intelligence, machine learning, or security, or any kinds of graphics. That's going to be computer science. And software engineering is more like how the software system are built, including the topic such as project management or quality assurance or software testing as well. So you should choose software engineering if you're more interested in more hands-on development approaches. If you want to learn like overall life cycle, how the software is built or maintained. So I would say that both computer science and software engineering actually teach fundamentals of programming and computer science, but the way they actually do the software engineering is more like focusing more for the life cycle in the software development. But computer science, after you learn this programming, you will try to see how we can apply this one with the logic in the end. So that's the difference there.
Perfect. Thank you very much, Karen.
Thank you.
Next question. Is it possible to do a double degree with engineering and computer science?
I don't believe so.
With with engineering, you can't. What you could do, I suppose, for example, you could do engineering with science, and within science, there's a major in computing.
Computer science, yep. You could do that, yep.
That's a way you could do it.
And there was actually another question, maybe Karen can answer this one, which is what's the difference between a degree in computer science and the Bachelor of Science with a major in computer science?
Yes, I can answer now.
And along those same lines, there's also another question about what's the difference between computing science in the science faculty and computing science in the engineering faculty.
So I can say this, the engineering faculty is the one you can actually majorly learn that computer science. And the science faculty, computer science, is more like we're teaching just the fundamental programming units only. You don't really need to do like more than like what we have. So it's more like, you can say that this computer science in the engineering one is more like expandable, that computer science one. And the other science faculty one, you need to learn the science as well as computer science. That's why you're not really fully focused on the computer science. So I can say like that. So if you want to say that, which one is like recognized by Australian Computing Society, I would say that the engineering faculty, the computer science is the one. Yeah.
Yes, thank you, Karen. Thank you, Ken and Anthony. Yeah, many questions are sort of similar. We'll try to answer as many as we can. There is a question here. Is it better to study a master's degree before a PhD or just do an honors bachelor degree?
I was just replying to this one, but I think, Carlos, since it was timely, I might just share that a bit. The honors degree and PhD obviously relates more to research. And so that's where you learn to think critically, and you are able to evaluate information that you've read, and you are able to ask critical questions, not so much necessarily finding what the solution is to the problem, but you focus on a very narrow problem that's of interest to you and your supervisor, and you basically try and study that phenomenon. Now, doing this does not necessarily mean that you will get a better job than someone who did not do an honors degree. It's a very different ball game, but in terms of developing yourself as a personality, I believe honors is a really great extra year of study, introduces you to the world of research, where if you're like me, I finished my commerce degree and I majored in computer science and accounting, and I really wanted to get out of university to experience the world. Now, I worked as a systems integrator in Telstra, and then after 2.5 years, I decided to come back and do my PhD. I haven't regretted at all after that, because being able to come to work and think about the interesting problems that I'm solving and hoping to contribute to the advancement of the society in that 1%, that gives me a lot of joy. So that's how I would approach it. Yeah, the focus is rather different. People who do a master's degree, for example, a master's in project management, are generally professionals who've been working, and they might have been engineers or computer programmers, and suddenly they realize that they're in a project management role. And so they want to upskill themselves, and therefore they come back and do a master's in project management.
And just a piece of advice for any international students we have at the moment. So I know in many countries you're required to do a master's degree before you do a PhD. In Australia, as well as many countries, it is not like that. You don't have to do first a master's degree to complete one to go to a PhD. Just for those international students, the thing is it's compulsory. As Ken was saying, it's just different ways to get into a PhD, but it's not compulsory to do one before the other.
Carlos, I'll also just add over here in my second reading of the question, you can definitely get into a PhD if you have a first-class honors, but basically if you don't have any research background and you finish a bachelor's degree, for example, and you're doing a master's degree, it's very advisable that you perhaps enroll yourself in some sort of research unit where you're able to produce a thesis or a dissertation, and that will then allow you space to go into a PhD degree, perhaps by doing a master's in philosophy first and then applying for a PhD.
I think that's good advice, Ken. And I would also add that during your undergrad degree, there's opportunities at Sydney University to do a vacation research internship.
Yes, like what Karen mentioned, yes.
Within the faculty, and that would certainly springboard you up to that research, beginning that research career.
Thank you very much. So there is a question here that is very particular about software engineering, but I think we can adapt it to all your different courses. So in this case, someone is asking, for software engineering, it requires 92 ATAR. If I only get 85, would it still be easy to get into software engineering in a lower ATAR course? I suppose I would change the course, the question, and say, for your respective, what happens if I don't get, the ATAR that I need? Does that mean I cannot get in? There are many different avenues. Is it very hard to get it? So as if you go to UAC, and you will see what is the minimum score, there are different pathways to get into university. If you don't get the required ATAR, there's different pathway for you to get into here. And even if you do not get the score to get to your preferred, let's say you would like space engineering, right? And that is that is 99, and you only get a 95. After you study 1 year, for example, of university, if your scores are high enough, you can always apply for a transfer with other areas. Now, we have another question here about admissions, but I think we'll leave those ones. Just for those who don't know or who are not aware, the university every year has an event called Open Day. That is happening in August 28 this year. That will be, so next month. It will be fully online because, as you know, the health situation that everyone is aware of. And then we'll have people from every single school, and we'll have all the people from admissions as well to answer those very specific questions about entry pathways, ATAR scores, etc. So you're more than welcome to come, register on our website, and you will be able to ask those very detailed questions. So let's continue with the next one. Well, Ken is answering this one, but I think it's, Ken, sorry to throw your question again live, but I think this is a good question. How do we know what combinations for combined degrees and majors are allowed?
Thanks, Carlos. That's for computer science, is it, or for in general? I've just put in a link there. There's a link called CUSP. CUSP stands for the Curriculum and Unit of Study Portal. It's a bit of a legacy site at the moment. However, it does give you a really good sense about what the degree options are. For example, if you're interested in engineering, it will allow you to see whether you can combine it with other degrees or not, and it spells out the entire degree plan plus the different units of study. So you'll see exactly, for example, if you're doing engineering and commerce, you'll see what subjects you're expected to study. And so it's sort of listed there. It's very exhausting for us to spell out all sorts of combinations, but particularly in project management, we do have the shared pool of majors where you can choose. And I think that website that I provided will give you a better sense than what I can answer in this space. So please do check out that link there.
Thank you, Ken. There's a question, I think we'll have to answer this one quickly. What is the difference between a Master of Architecture, Master in Civil Engineering, and Master in Architecture Engineering? Well, we don't have Master in Architecture Engineering. Let's start with that one. There's Master in Architecture and Master in Civil Engineering. They're two, even though may sound to some people similar, and we do offer a combined degree in Civil Engineering and Architecture, they're different ones. No? If you would like to know more about these particular master degrees, please go onto the website. You'll be able to read a full description of exactly what this course is about, and more importantly, what are the entry requirements. How do I apply for the Bachelor of Commerce with a Bachelor of Engineering Honors Space Program? So when it comes to combined degrees, like we said before, you can do engineering with business, with commerce. So you just apply for a combined degree, 5 years for those two. Second question, can I move from a flexible first year degree to specializing in space engineering in the second year? I believe, Anthony, unless I'm mistaken, as long as you have the grades, you're able to get into space on your first year.
It's possible, but very competitive. Not easy to do.
Yes. Sorry, Karen, that we keep asking you the same question, but I think one of the most popular one, it's always, what is the difference between software and computer science? And even though we do answer the question a lot, perhaps we have new students that are coming to listen to us, no? So this is a particular question. I think.
I just answered.
Yes. Oh, you were answering that.
Yeah, I typed it. So yeah, because I can see several students actually ask like computer science and the software engineering, computational data science, all those things. So computer science is more like, so both computer science and software engineering and computational data science, we all require to understand the programming at the first time, because that's the starting point. After you start the computer science will actually goes to more like, after you learn the programming, how we can apply this one together with like AI or machine learning or security, any kinds of logical thinking. It's more like Google or Amazon. Software or system using this idea. And software engineering is more like focusing on how the software system are built. So it's more like software testing and then building that actual hands-on approach to understanding the overall life cycle of the software development. That's the software engineering. And computational data science is using this programming. You need to understand how you can actually apply and analyze this the data. How do we handle this data in order to finding out some useful idea in terms of like medical field or financial fields. A lot of actually students who's kind of working in like combining with another area like finance or medical, they do this computational data science more. But if you really focus on like technical company or go to technical company in the end, or that is more like focusing on the computer science. Yeah, in that case.
Thank you, Karen. Thank you very much. Next question. If I want to do a PhD in physics and take a degree in engineering honors and Bachelor of Science double degree, then can I bypass my Master of Science and go to PhD? I suppose, and can answer this before, is if you do, if you get a first class honors?
Yes, I think if you are able to obtain a first class honors, that is really your ticket into a successful application for a PhD. Otherwise, because I believe in the engineering honors degree, you have to do a thesis component, and that obviously involves, a great deal of research then. So a first class honors is what you want to target in that case.
Thank you, Ken. Karen, this is a student apologizing in case it's similar. I think this is maybe a slight difference. So he's asking, what is the difference between data science in the science faculty and computational data science in the engineering faculty?
Data science in the science faculty is a math degree. So the math school actually handled this one. So we don't know about this one. I didn't know about this one, but it's more like math. So they learn more for the math lab and then just running up for this logical and then theoretical more. But computational data science is learning this programming and then making up with analyzing the data with the computer science technology.
And I think that's all we have time for today. It's almost 8 p.m. So before we say goodbye, Anthony, Ken, Karen, would you like to say brief words about to any students that are considering coming to study with us in your areas?
Yep, I'd say if you still have questions, come to our open day. And we've got booths planned for open day with much more specific topics to be handled there. So, you might get a bit more specific answers than what you may have been able to get tonight. Best of luck with your studies.
Absolutely. Yeah, and please do reach out to us, particularly in the School of Project Management, as with all the schools in engineering. We're more than happy to provide you with more information to basically help you succeed and, have a fantastic journey in education here.
Thank you very much for the really qualitative questions. It was really nice to see how the students actually ask about this, what sort of topic they are interested in. So if you have any kinds of question, you can share us anytime. So we're just trying to answer and let us know. So I can really still see that several questions about just AI and the computing. If I can help a little bit answering, like even after this meeting, I can just answer. Yeah, I hope I can see you in this computer science degree in the USID. Thank you.
Thank you, Karen. And don't forget, Open Day will be fully online from 10 to 2 p.m. So you can just log in from your house, and we'll be there to answer any and more questions that you have. Thank you very much, and a big round of applause to our 3 panelists. It was a pleasure having all of you so late today. As you know, it's already dark. I don't have to tell that to all of you. And everyone stay safe, no? And thank you very much. Good
Thanks,
night.
Carlos, Dario, and the team for managing this as well. Thank you.
Thank you.
Bye-bye.
Bye.